Hello, here is your key for number 19. As you go back and check your work, make sure that you actually think about the problems. Don't just change the numbers. As usual, you should have your partner. Mine is Gruffalo. You should read it without the numbers. They are written with numbers, but you'll just have to ignore the numbers. Think about the question, and then actually solve it with the numbers themselves. Okay, so Tommy's dad is teaching him how to make a table, so I'm picturing myself, picturing Tommy making tables, and it says Tommy makes a small table. Okay, so I can picture him making the table. And the question is, how many square foot tiles does he need to cover the top of the table? So I can picture a square foot tile, and I want to know how many of those there are. And now I'll go back and look at the actual numbers. This table is 3 feet wide and 4 feet long. 3 feet wide, 4 feet long. And I want to know how many tiles. So each of these squares can be a tile, and I can see 12 there. I could also just say 3 times 4 is, 3 times 4 is 12. So 12 square foot tiles. And you should either type right here what we just did, or you can work it out and take a picture and attach it. It can be one picture for all your work, by the way. Okay, now there's more. They're making more tables. Oh no, how many feet of decorative border material? Decorative border material. Okay, so we're talking about the border of this table. So we are talking about the border. The other word for this is perimeter, right? So what's the perimeter? We've got 3, 4, 3, 4, 3 and 4, and 3 and 4 equals 14. So we need 14 feet of decorative border material. But then Tommy's dad makes an even bigger table. Still picturing the same thing. This one is 6 feet wide. 1, 2, 3, 4, 5, 6, and 8 feet long. 1, 2, 3, 4, 5, 6, 7, 8. I can count up all those squares, or I can say 6 times 8 equals 48. And they are asking, when both tables are placed together, what will their combined area be? So we're putting these tables side by side and doing their combined area. So this one was 48. This one is 12. So 48 plus 12 equals 60. So 60 square feet for their tables together. Okay, 2A, they're asking kids at Park Elementary, and Park High School has several times as many. So I'm picturing all the kids at the elementary. That's about the same as for the Park Elementary School, Weyerhaeuser Elementary School. I can picture all those kids. And if we put them together with the high school, how many kids will there be? And that is the question. How many students will attend both schools? So I can picture putting all those kids together. Now I'm going to consider the 400 kids here and 4 times as many at the high school. So 4 times as many at the high school as there are at the elementary. 4 times 4 is 16. So we've got 1,600 students at Park High School. Now this wants to know both schools together, so I have to add the elementary kids onto that, which seems like 2,000 students. That's a lot of kids. Again, you're either going to explain what we did here about the multiplying and the adding, or you attach a picture of your work. Now this goes on. There's 5 times as many students at Lane High School, still Park Elementary, so the same kind of thing. So I've still got the same 400 kids at Park Elementary, but 5 times as many at Lane High School. 4 times 5 is 20. So I've got 2,000 kids at Lane High School. How many more are at Lane than Park? So Lane had 2,000, Park had 1600 or 1600. There we go. Subtract, and we get 400. So 400 more attend Lane High School than Park High School. Okay, number 3. 3 students on a relay team, and they each run a certain distance. I can picture them running, and they each run the same amount. And my question is, how many total kilometers does their team run? Okay, so I can picture that. I can picture adding up all 3 of their runs. Now I'll go back and look at the number. It's 1 3/4 kilometers, so I have 1 3/4 for the first kid, and 1 3/4 for the second kid, and 1 3/4 for the last kid. And I just got to add it all up and figure all this out. And it's probably simple to do the 3 ones. That's 3, but what's all this? Well, we know fourths, the denominator stays the same. So it could be 9/4. That's an improper fraction. So we can't leave it at 3 9/4. Another way to do this is to use this number line down below. So that first kid ran 1. There's a jump of 1 on the number line. And then 3/4. 1 2 3/4. Plus 3 more fourths. And then the second kid did 1, and it's a little harder to think of 1 here, but if you notice that there's 1 2 3 4 jumps, so a jump would have 4 little fourths. 4 fourths makes 1. So there's my 1, and then 3 more. And the last kid did 1. Again, it's a jump of 4 ticks, and then 1 2 3. And it looked like we ended at 5 1/4. So is 3 9/4 the same as 5 1/4? So one way to think about this is 4/4 makes 1. We just said that. And another 4/4, that's 2, and a total of 8/4. So 1 more fourth. And this ended up being a 1, and this ended up being a 1. So 3, 4, 5, and a 4. So 5 and a 4. And of course, you either explain how we did all that here, or you take a picture of your scratch paper. Okay, there is your key for lesson 19.